In this mini lecture, we're going to work with the tab for marketing information, okay? And in this first set of data that we'll work with, this set of data right here, okay? The company's interested in what marketing factors might most influence a company's net income. So we gathered data on a number of different companies, and we found out how much money they spend on advertising. We found out how many salespeople they hire, and we got ratings of the company's overall product quality. So you can see here that we can use three independent variables: advertising, number of salespeople, and product quality. We can use those three independent variables to predict our dependent variable, net income. And advertising is ratio and scale. Salespeople is ratio and scale. Product quality, we consider that to be an intervally scaled variable. Orist, being somewhat the purist that he is, would consider this to be ordinal data. But in the marketing world, we treat these data here as interval and scale. And in this instance here, in terms of product quality, 1 would be very, very poor quality, and 7 would be very high quality. Okay? So while we are inclined to want to predict our dependent variable, net income, based on our three independent variables, the first thing I'm going to do is I'm going to look at a correlation matrix just to see what's going on here. And so I'll click on add-ins, and then I'll go to Megastat, and I drag down to correlation and regression. Then I drag across and down to correlation matrix. Okay. And I'm going to highlight my column headers. Notice I'm not highlighting my column header or the data for company number, only the column headers of my variables of interest, and then I'll highlight all the data. And I'm not sure how much data I got here. And I click on OK. Now here, because of the way the data are structured, this is really a row in which I'm highly interested, because net income is my dependent variable. So we've got a moderate correlation with advertising, we've got a strong correlation with number of salespeople, and we have a kind of a weak to moderate negative correlation excuse me, with product quality. Okay? And I look here and I see I might have a problem with multilinearity, because advertising and salespeople are pretty strongly correlated. Although with the sample size of 120, it may not turn out to be too much of a problem. Nevertheless, I like to look at my correlation matrix to kind of size thing up. I'm thinking that for sure salespeople is going to have a statistically significant predictive impact on salespeople. I think advertising will. I don't know that for sure. And product quality has a chance. You just don't know for sure. Okay, but for sure, looks like salespeople is going to rule the day. So I go back to my tab for marketing info, and this time I'm going to run regression analysis. And remember, excuse me, in Megastat, your independent variables have to be adjacent to one another. Okay, and in this instance, they are. So I'm already at add-ins, so I click on Megastat, and I drag down to correlation/regression. I drag down to regression analysis. Let me clear everything out here once. Okay. And it wants my independent variables, so I highlight my three column headers for advertising, salespeople, and product quality. And then I also highlight all of my data. Okay. And then for my dependent variable, I do the same. Highlight the column header, net income. All of my data. Now I'm going to ask for the variance inflation factor. I think I'll ask for the standardized coefficients, and that's probably all I'm going to ask for at this point. Okay, so I'm ready to look at my output. Excuse me. And adjusted R squared about 60%. This is a pretty good regression model. Not surprising, we get a small p-value here. Okay, so I know that my regression model helps predict my dependent variable. I know that I've got a really good model. I mean, when you can explain 60% of the variance in a dependent variable, that's mighty good as far as I'm concerned. So then we direct our eye over here, and kind of to my surprise, the p-value for advertising and product quality are both greater than 0.05. So technically what that means is, unless I have a problem with multilinearity here, I really only need one independent variable in my model, and that would be the number of salespeople. So while I thought I was going to run a multiple regression model, maybe I'm fine just running a simple regression model. And if I look at my variance inflation factors, they're not even close to 3, okay? So I think I'm comfortable running just a simple regression. And let's keep in mind that the adjusted R squared is about 60%. So I'm going to rerun this model now as a simple regression, and I'm going to see what happens to my adjusted R squared, or since it's simple regression, my R squared only having salespeople in the model, okay? So we go back to column for marketing, or the tab for marketing info, all right? And I'm already at add-ins, so I go over to Megastat. I drag down to correlation and regression. I drag across and down to regression analysis. Now my dependent variable is going to remain the same, but I have to highlight a different area, only the number of salespeople, from my lone independent variable. Because remember, I'm going from multiple regression to simple regression here. So I don't need the variance inflation factor. Don't really need the standardized coefficient. So I click on OK. And the first thing I'm going to want to look at is my R squared here, and see it's 60%. So even though advertising and advertising and product quality, even though they were significantly correlated with our dependent variable, from a predictive modeling standpoint, the number of salespeople alone was adequate to predict our dependent variable net income. When we had 3 variables in the model, our adjusted R squared was 0.593. With only 1 variable in the model, it's actually 0.597. Okay, all right. So here we would say that here we would build a regression model of net income is equal to minus 31 plus 0.554 times the number of salespeople. Make this a little bit bigger once. Okay. Now remember, these are in thousands, so the net income's in thousands. So if a company didn't have any salespeople whatsoever, we would predict that it would lose $31,000. Okay, and then for each additional salesperson, it would increase net income by 0.554. Okay, which you have to multiply that by 1,000 because net income is in thousands. All right, but this becomes our regression model. Even though we started out with multiple regression, with these 3 independent variables here, at the end of the day, we only needed to do simple regression with a number of salespeople, and that simple regression model is more parsimonious, but every bit as good as the multiple regression model that we started out with. Thank you.